Welcome to exercise 5.10. We're talking about limits and continuity here. Now, there's the languages that we need to understand with limits. When we see that written, we read it as x approaches infinity. Sometimes people say as x tends towards infinity, but normally we read it as x approaches infinity. In other words, when x is becoming a massively huge number. When we see this, we say the limit as x approaches infinity. So it's some language that we need to understand there. So let's try doing some questions. The first one says, find the limit as x approaches 0 for this question. Well, what happens if x was 0? You look at it and you go 5 times 0. Well, I know that, that's 0. Plus 3. Well, that's just 3. So you could actually look at that and just say, well, let's let x equal 0. If x is approaching 0, what happens if it is 0? You get an answer of 3. Well, that's pretty straightforward, and that's your answer. Let's go to question 2 and see if the same thing works. The limit as x approaches 0 of x squared plus 3x over x. So if I let x be 0, I get 0 squared plus 3 lots of 0 is 0 over 0. Now that's a problem because you can't have 0 on the bottom of a fraction. That doesn't make sense, which means this method doesn't work. I have to come up with a whole new approach for this question. And this is the approach we're going to adopt. There is 2 methods we could use. I'll show you both. The first method is this. We rewrite the limit as x approaches 0, and we always look to take out a common factor on the top. You always factorize. And if you can't factorize, you'll use the second method. But when you factorize, you'll notice that the common factor will cancel with what's on the bottom, which means this question now simply reads the limit as x approaches 0 of x plus 3. Can I let x actually equal 0 now? You get 0 plus 3, that makes sense. The answer is 3. Here is a second method you could use. Now if I'm going to say let x approach 0, that means x is a number close to 0. So we might say something like this. Let x equal 0.001. That's a number close to 0. If I wanted it to be closer, I'd go 0.00001, but that's a number close to 0. So in the question, where you now see x, you replace it with 0.001, and you would get 0.001 squared plus 3 times 0.001 over 0.001. Now I've got a calculator next to me here, so I'm going to put this into the calculator. 0.001 squared plus 3 times 0.001 over 0.001, push equals, and the answer is 3001 over 1000, which if I push s to d is 3.001. Now the whole purpose of using this method is, what is the answer close to? Well, 3.001 is very close to 3, so I'm going to assume that the limit as x approaches 0 of x cubed plus 3x over x is equal to 3, because that was very close to 3. If I wanted an answer closer to 3, I could have tried x equals 0. Something like that. And that would have given me 3.00000, a whole lot of zeros and then a 1. But that's a process. But it's far easier to take out a common factor and then cancel. So let's look at number 3. Now this one here. If I let x equal 3, I'd get 3 squared, take away 9. 3 squared is 9, 9 take 9 gives 0. And you can't have 0 on the bottom of the fraction, which, remember I said, we'd have to factorise. So let's have a look at what we've got here. The limit as x approaches 3 of x take 3. That's not going to change, but on the bottom, x squared take 9 is a difference of 2 squares. So that would become x take 3, x plus 3. And then you can see that I've got some brackets that are the same. They go into each other once, they'll cancel, which will leave me with the limit as x approaches 3 of 1 over x plus 3. Can I actually replace the x with 3 now? Well, if I do, I get 3 plus 3 is, I get a 6 on the bottom. I don't get a 0 on the bottom, which is good. So I'm going to do that. I'm going to let everywhere I see an x, I'm going to put 3 in its place, and I get 1 over 3 plus 3, which is 1 over 6. Notice I kept the limit as x approaches 3 right through until I actually plugged the x value of 3 into the question. Now, question number 4 is very confusing to look at, but it's actually starting the concept of introduction to calculus, which we'll talk about later. But notice, for this question, I'm limit as h approaches 0. Now, h can't equal 0, because if h was equal to 0, I'd get a divided by 0 error, which means I need to somehow rewrite this question so it's the limit as h approaches 0 of. On the top, I'm going to take out a common factor of h. I don't care if there are other common factors. All I want to take out is the h, because if I do that, I can then cancel it with the h that's on the bottom of the fraction, which means I get equals the limit as h approaches 0 of 4hx minus x squared minus 10. Now if I let h be 0, that part drops out, or that part will stay there. So letting h equal 0, I end up with minus x squared minus 10, and there is my answer. Now, we continue on to continuity. It's in the same exercise. It's similar to limits, but continuity talks about whether a graph just continuously goes along. I could draw a graph like this. I could say, here is a straight line that exists for every point except for that point there. There's a break in the line. There's one point missing. And that makes the line discontinuous. Now, it might not look like it, but that there is actually a straight line. So let's see if we can figure out why. Now, if we actually let x equal 2 for this question, x squared minus 4 over x take 2. If I let x equal 2, I get 2 take 2 on the bottom, which gives me a divided by 0 error. So I have to go about this process of thinking about it like this. It becomes the limit as x approaches 2 of, on the top, I have x squared take away 4. That's a difference of 2 squares. So it's x take 2. X plus 2, and on the bottom I have an x take 2. I can see that there's some cancellation going to take place there, which equals the limit as x approaches 2 of x plus 2. That's all that's left. Well, now I can plug in an x value of 2. 2 plus 2 is 4. Now, what that actually means here is that if I was to graph y equals x squared take 4 on x take 2, it's almost the same as the line y equals x plus 2, because that's what it cancelled down to here. But the difference is y equals x plus 2 looks something like this, and it goes forever. Y equals x squared take 4 on x take 2 goes like this, except there is one point somewhere about there that's got an open circle, so there's nothing coloured in inside it. Open circle there with nothing inside it, and that would be the point 2, 4. Out 2, up 4, there's a break in the line. So if we know that's the case, How do you describe the domain now? Well, the domain is all real x except for x equals 2, because it can't let x equal 2, or you've got to divide it by 0 error. As for the range, all real y except for y equals 4, because that point there that doesn't exist has a y value of 4 and an x value of 2, and that's where your y value of 4 and your x value of 2 come from. And you'll see there's your 4 and there's your 2. So the domain and the range of that particular graph are listed there. Bit weird, I know, but with practice you'll get to understand it. The next one, if I let x equal minus 2, I get minus 2 plus 2 on the bottom of the fraction. I get divided by 0 here, so I can't let x equal minus 2 yet. I have to factorize. So we're going to look at that limit and then sketch this curve, which is the same without the limit there. Let's see what happens with our limit. I keep the limit as x approaches negative 2. Now, the top of the fraction is a quadratic. What two numbers times to give negative 2 and add to give 1? Well, that would be x plus 2, x take 1. And if I look at my question, I can see that I've got some brackets that cancel, which means I end up with the limit as x approaches negative 2 of x take 1. Can I let x be negative 2 now? Yeah, sure, I can't have any divided by 0 problems, so negative 2 take away 1 gives negative 3. Now, this curve here looks confusing, but it's exactly the same as the curve y equals x take 1, because that's what it cancelled down to, except there's a problem with it. Y equals x take 1 as a 45-degree angle, because that's what y equals x is, push down 1, so it goes like this. But there is a point that doesn't exist, and that's the point minus 2 comma minus 3. So if I go left 2, down 3, that point doesn't exist on the curve. So there's my sketch. I need to make sure that I don't, where I have that circle there, there's nothing in it, it's hollow, and I continue on left and right forever. So there's a sketch of my curve.